Now, I don't know about you, but 4.2 light years is a number I can kind of wrap my brain around. I realize a light year is a really large number, and 4.2 is not. So 4.2 light years makes sense to me. This number, 39.9 with a whole pile of zeros, does not make nearly as much sense to me. I just can't wrap my head around how big that number is. So this is really why we have this concept of the mole. Another example, at the atomic level, how many gold atoms are there in a typical gold ring? Well, if we assume that there's, say, at least 1 gram of gold, that's not a lot. 1 gram of gold, there would actually be about 3 times 10 to the 21st atoms of gold in that ring. So it's these sorts of numbers that bring us to using this chemical, this amount, the mole. So the mole is the SI unit for amount. The SI stands for System International, and that's all those different kilogram, gram, that sort of thing. And so in chemistry, this amount is usually entities. And I've already explained entities, atoms, molecules, ions, that sort of thing. And so in chemistry, these amount of entities would be huge. They'd be far too large to comprehend really from a numerical point of view. So we convert them to an amount in moles, a number, again, that's a lot smaller, a number we can wrap our brain around. And then we just realize that when we say mole, we're really referring to a really large number of particles. So again, you can think about that relationship, the relationship between a mole and a number of atoms, similar to what we just talked about, similar to how you think about light years and an amount in kilometers. It's the same idea. Now, the Avogadro constant is the number we use, Na, and it's the fundamental physical constant that links the macroscopic physical world of objects that we can see and feel with the submicroscopic and visible world of atoms. I like that quote, because basically what it says is macroscopic physical world, that's stuff we can see, stuff we can count. We can see amounts, we just don't realize how many atoms are involved there. So in theory, Na specifies an exact number of atoms in a physical amount of an element, such as carbon or water. So the Avogadro constant allows us to convert between this amount of atoms or molecules to an amount in moles. And so here we actually have a couple of molar amounts. So this is 1 mole of carbon shown here, and that's about 12 grams. This is 1 mole of water molecules, and that's about 18 milliliters. So this is what we mean by linking the physical world to the subatomic or submicroscopic world. Physical, 12 grams of carbon, that's 6.02 times 10 to the 23rd carbon atoms. Physical world, 1 mole of water, that's 18 milliliters of water molecules. That is, again, 6.022 times 10 to the 23rd water molecules. So the Avogadro constant, entity 6.022 times 10 to the 23rd entities per mole, so we express it as entities per mole.